All right, the last section on 7.2 is going to ask you to find different angle measures that will have certain sines or cosines. And I kind of have an idea in mind here of what I want people to be looking for. I'm not sure the problems that I picked quite take us all the way, but it's something we're going to build on in section 7.3. So here's the idea. Cosine's a fraction, right? So the first thing you want to do is you want to say 1 over 1. And by the way, I'm not using an x here. I'm going to use a theta to represent my angle measure instead because our cosine definition actually has, our sine and cosine definitions have x's and y's and r's in them, and those are side lengths of triangles, not angle measures. And so I think that makes it kind of confusing. So I'm going to change it just slightly. Cosine of theta equals 1, and we're going to write it as 1 over 1. So remember, cosine is an adjacent side over hypotenuse. So really, I just want to make a triangle where I have that sort of thing happening. Now, the other way to think about this, remember that cosine also can be defined as the x-coordinate over the radius. And that might be a little bit better because this is telling me that I have to have, and by the way, you could do anything that simplifies to 1. You could do 2 over 2, 3 over 3, 4 over 4. But I like this 1 over 1 because what this is implying is that I need to make a circle with a radius of 1 to draw my picture. Okay? Because I need my r value to be 1, and so that applies to all the r's all the way around here. I need to find a point on this curve that has an x-coordinate of 1. And if this circle has a radius of 1, then that means it's passing through 1 and 1 and negative 1 and negative 1 on the different axes. There's only one point here that has an x-coordinate of 1, okay? So that's the point 1, 0, and my radius value there would be equal to 1. And so you can't actually make a right triangle with that. But according to the definition, the x-coordinate divided by the radius would give you a value of 1. So what's the angle measure here? Well, this is a point that the terminal side is passing through. So we're saying the angle starts here at 0, 0, and it also, or at 1, 0, and it also ends here. This is a 0-degree angle, okay? If you go take the cosine of 0 on your calculator, you're going to find out that it's equal to 1. Now, it asks you for other possible angles. Sometimes you'll be able to find other possible angles between 0 and 360, okay? However, you notice in this case we need an x-coordinate to be 1. Literally, that's the only point on this entire circle that has an x-coordinate of 1. So the only other thing you can do is to find a coterminal angle. You could add 360 degrees, you could subtract 360 degrees. In this particular case, it's going to be 360, okay? Let's say that I'd ask you something slightly different. Let's say, and this is not one of the homework questions, but I want to kind of build on this. So remember I said sometimes you can get multiple answers between 0 and 360. Let's say I had said tangent of theta was equal to 1, okay? Tangent of theta equal to 1. Well, if I'd done tangent of theta equal to 1, of course that's 1 over 1. Tangent is opposite over adjacent. And I could use that setup, but I think I'm going to use y over x instead. And again, you could do 2 over 2, you could do 3 over 3, and so on. But this is implying that if I'm making a circular motion, I've got to find a place where my y-coordinate and x-coordinate, that fraction simplifies down to be 1, okay? And so I'm going to do that same circle again. I'm going to do a circle with a radius of 1 again. Okay, this is slightly challenging in a different way, but still not a big deal. Here's the key. It actually doesn't say that y and x have to be 1. It says that the quotient has to be 1. Okay, so for example, if you plot something here, you're going to have an x of 1 and a y of 0. Okay, that fraction's not going to be equal to 1. If you did something here, you're going to have an x of 0 and a y of 1, and that fraction's also not going to be 1. Okay, if you think about it, for y divided by x to be equal to 1, or for the opposite over the adjacent to be equal to 1, if you want to think about that, these two values have to be the same. So again, they don't have to both be 1. They could be 2 and 2, 3 and 3, radical 2 and radical 2. Doesn't matter. Where on this graph do x and y have the same coordinates? Well, right here, okay? You're going over an amount, you're going up an amount. Think about it. That's a right triangle. If that length is equal to that length, What kind of right triangle is that? That's a 45, 45, 90 right triangle, okay? And so actually, if the radius was 1, this would be 1 over radical 2, and that'd be 1 over radical 2. This is going to get kind of messy. But the point is, the x and y coordinates are the same, okay? The tangent of 45 degrees is going to be equal to 1. Now, there is one other place that this can happen on a circle, okay? Where else could I have two values divide and get 1? Well, I can't do it over here because x is negative and y is positive. I get negative 1, okay? But down here, when x is negative and y is also negative, I'm going back and down the same amount. Back the same amount in the x direction, down the same amount in the y direction. That's a 45-degree angle there, okay? What's this angle measure? Well, it's 180 plus 45, that's 225 degrees. Okay, if you go to your calculator, try the tangent of 45, you'll get 1. Try the tangent of 225, you'll also get 1. So it is possible to find multiple angles, usually 2, between 0 and 360 that will meet some of these definitions. Now, some of these, you're just going to have to do a coterminal angle. You're just going to have to add 360. But sometimes you'll notice these are not coterminal. Okay, I didn't add 360 to 45 to get 225. However, if I did add 360 to that, I would get another angle that would come back to the same place that would also have a tangent of 1. Okay, so a little bit of background there, probably going a step beyond what this section intended, but that's kind of where these problems are headed.